All right, here's a review problem for your quiz on converting to vertex form by completing the square. Now we're not solving it. The difference with solving is we bring that 16 over to the other side. This one we want to keep it as it is. So to review, what do we do when we complete the square to convert to vertex form? What's our first step?
Is completing the square where you take half of the b, I think it is?
Yep, half of the b.
So that'd
and
be
square it.
-3.
Yep. So I'm going to first just group. It's too bright of a color. So. I was trying to change up different colors and have some fun with it. So I group the a and the b term, and I throw that c at the end. And now we, like you said, take half of the b, which is -3, and then we square it. And we get 9. And what do we do with that 9?
Plus 9 in the parentheses and minus 9.
Very good. Plus 9 in the parentheses, and then to undo it, minus 9. So now we have y equals, and now we factor. This is a perfect square trinomial. Those go pretty fast. Or remember your chart method. What are the factors of 9 that add to -6?
2 -3.
2 -3. This always would be perfect square. So it's going to be x minus 3, or erase this, x minus 3 squared, and then off to the side, 7. 16 minus 9 is 7. So then if I asked you for the vertex, the critical point, what would you say it is?
9.37.
3, 7. Opposite of the h, right? And then the same k. Good. So that's how you convert to vertex form. What other topics are you shaky on? How about like the absolute values of imaginary?
Yeah.
Okay, let's say we give you a problem like this. We want you to find the absolute value of a complex number. Look and tell me what we did there. Square root them, yep. So we have a square root. And then what? Square each number. So 3 squared plus 4 squared. What if there was a negative here? Do we care? No. So then we have 9 plus 16, which is 25. And then the square of 25 is 5. This happens to be a nice number. I made up the problem too. What other things are you shaky on?
How about we could do 1 adding with the
Complex numbers?
yeah.
Sure.
And 1 multiplying with the complex numbers.
How about like that? Does that look good?
Yeah.
Alright. So what do we want to do first? FOIL distribute, yep. So we distribute the 4 in. Then we get 4 plus 4i. Anything to distribute in that second parentheses? Nope. And then some students are going to just kind of group them together and then combine like terms. It might not be a bad idea, so you don't forget anything. So those will be like terms, the reals, and then the imaginaries. So 4 plus 5 is 9. 4i minus 7i.
3.
I. You always put your real part first, then your imaginary. I do have a subtracting one. Do you want a subtracting one?
Sure.
Sure.
So the difference there is students make mistakes on this piece right here. They forget to distribute into that second one. So we'll do the same thing. We'll distribute the 4. So we get 4 plus 4i. And then what do we get in the next two terms?
-6 and +7i.
Very good. All right, so now we combine like terms. 4 and -6 become
-2,
-2. 4i plus 7i,
11i.
11i. I'm not multiplying. Big mistake there. Students want to, on question A, they want to distribute in. There's actually 2 parentheses there. It's really 7 minus 2i and 7 minus 2i. Which now what do you have to do, Chris? Foil it out, yep. So you'd foil 7 times 7 is 49. 7 times -2i is -14i. And then 2i times 7, -14i. And then -2i times -2i is plus 4i squared. And then combine your like terms. -28i. And then what happens, do we say, with the I squared?
It becomes a -1.
Becomes a -1, or drop the sign, or drop the I and change the sign. Drop that I squared and change the sign. So we have one more pair of like terms there. 45 minus 28i. How about dividing? Why not? Simplify these expressions.
Take the denominator out.
Yep, the conjugate of the denominator. So I'd probably throw parentheses around all those. And what's the conjugate of the denominator?
5 plus 2i.
5 plus 2i. It's always the sign change of the imaginary part. And now what do? Foil and foil. So we get 15, 6i, 20i, 8i squared. Then you do the denominator. What's the shortcut on the denominator? Just the first and last, because complex conjugates, the middle terms cancel out. So I only have to worry about the first, 5 times 5, and then -2i times 2i. What's that? Combine my like terms again. 6i and 20i, 26i. And then what happens? -8, 8i squared becomes -8. 25 plus 4. Combine like terms again. Over 29, and then break that off into 2 pieces.
Now you forgot
Minus
the
the-
-8.
Oh, I forgot my -8. 15 minus 8. 7, and then break it off. Same thing with question D. What would be the complex conjugate of, if I had this, 1 plus 2 over I over I? -I. We multiply the numerator and denominator by -I. What about discriminants or quadratic formula? You good on those? Yep. State the discriminant, that one, or quadratic formula? Okay. One of the things you have to make sure you do before you start out the quadratic formula is make sure it's in standard form. Is this in standard form?
No.
Nope. What do I need to move?
Minus.
Minus 9x. Then identify the A, B, and C. What's the A?
1,
What's the B?
9.
What's the C?
5.
5. And now I throw it into that quadratic formula that you do have to have memorized in this course. Now I throw those numbers in. Be very careful. Throw your parentheses. Negative b, so it's a negative 9, plus or minus negative 9 squared, minus 4 ac, oh, I'm gonna run out of room, all over 2a. Now we start to reduce. Negative 9 becomes 9, plus or minus 81
Minus 20.
minus 20 over 2. Reduce the radical.
So you got like 61.
61. What's the fancy word underneath that radical called? What's this thing?
This is a discriminant.
It's the discriminant also. So the discriminant is positive, so that means I have how many real solutions? 2. And then you try to reduce down that score to 61 if you can. In this case, we can't. So we're done. Stop recording there.